Okay, I'm going to start chapter 5 here. We're only going to do chapters, sections 5.1, 5.2, and 5.4. So, and the main topic that we're going to talk about is systems of linear equations. Okay, so in section 5.1, it's all about systems in two variables. I got some examples of systems here just to start off. So a system is where you have one or more equations and there's one or more unknowns. So like if I had the system given by the equations 2x plus y equals 5 and negative x plus 3y equals negative 6. Okay, we use a bracket usually to enclose all the equations in the system. Okay, so this would be a system of two linear equations and there's two unknowns, the unknowns being x and y. And of course the idea is to solve the system. So find x and y such that it's going to be a solution to each equation in the system. Okay? So how about, what if I try x equals 1 and y equals 3 for this system? Okay? So, you know, the reason why I'm choosing 1 and 3 is because 2 plus 3 is 5. Okay? But if I put that in the bottom equation there, x is 1 and y is 3. Negative 1 plus 9 is not negative 6, right? Because I get 8. So 1, 3, that's not going to be a solution. Okay, with some kind of playing around with the numbers, I can try x equals 3 and y equals negative 1. So let's plug that in here. Is it true that 6 minus 1 is 5? Yes. And it's also true that negative 3 minus 3 is negative 6? Yes. Okay, so 3, negative 1, that would be the solution to the system. Or I could say x equal 3 and x equal negative 1. That's the same thing. Okay. Some other examples of systems are like this one. If I had the system of equations given by x plus y squared equals 2 and 2x plus y equals 4. Okay, this would be a non-linear system. Now, we're not going to work with any of these types. In other words, the systems that we're going to have are all going to be linear systems. So you won't have to worry about like an x squared or, you know, square root of x or an e to the x or an ln of x or anything. Those are not lines. Okay? And we're going to be focused on lines here. Another example is the system given by x plus 2y plus z equals 6, and then 3x minus y minus 5z equal 2, and x minus y plus 4z equal negative 1. So that would be a system of three equations, and there's three unknowns, or it'd be a 3 by 3 system. Okay, the three unknowns being x, y, and z. And the idea is the same, you know, so find x, y, and z such that all three equations would be satisfied. Okay, we're going to do some things with 3 by 3 systems in the next two sections primarily. Okay, so in this section we're going to focus on just 2 by 2 systems. Another example would be if I had the system of equations given by x plus 4y minus z equals 7, and then y plus z equal negative 3. So that would be a system of two equations, and there's three unknowns, x, y, and z. In other words, the number of equations doesn't always have to match the number of unknowns. Okay? And the idea would be the same, you know, find x, y, and z such that both equations would be solved at the same time. Now, if an equation has no solutions, it's called inconsistent. Okay, and we'll see some examples of that. On the other hand, if a system has infinitely many solutions, it's called dependent. We'll see some examples of that. Otherwise, if a system only has one solution, it's called independent. Okay? Now, there are three methods in this section for solving a system. They are the graphing method, the substitution method, and then the elimination method, or sometimes we call the elimination method the addition method. It's the same thing. So let's start off with the graphing method first. Okay, and I'll give you some examples. So what if I wanted to solve the system given by the equations x minus y equal 5 and 2x plus y equal 1? Solve the system. Okay, and I'm going to use the graphing method, so I need a graph. And let me get each of these lines into slope-intercept form. So let's solve for y on each one. On this first line, I'll add y and subtract 5. And so y equals x minus 5. And on the second line, I'll subtract 2x. So y equals negative 2x plus 1. Okay, and these are the two lines that I've got to draw. The first line has a slope of 1 and a y-intercept at negative 5. So 0, negative 5, I can use that as a start position on the graph and work off of the slope. The slope is 1. So I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And if I go up 1 to the right 1, or if I continue doing that, I should cross through the x-axis at the point 5, 0. Okay, and then once I have a couple points there, I can draw the line. And the second line is y equals negative 2x plus 1. So this line has a slope of negative 2 and a y-intercept at 1. So 0, 1, we can use that as a start position and then work off the slope. The slope is negative 2. So if I go up 2 into the left 1, up 2 into the left 1, or going up 2 into the left 1, the same thing as going down 2 into the right 1. Okay, and if I go down 2 in the right 1 a couple of times, I can gather up some points, kind of flowing in this other direction. And so once I have just a couple of points there, I can draw on that second line. Okay, now when you're using the graphing method, your answer is going to be wherever the lines intersect. So, it's important to be neat with your drawing. You don't want to slop up some quick thing and have to eye down where you think the two lines intersect. Because otherwise, if you're doing it like that, that kind of defeats the purpose of using the graphing method. So it looks like these two lines intersect at the point when x is 2 and y is negative 3. Okay, and to be sure of that, I can plug x equal 2 and y equal negative 3 into the equations there. I highly recommend to check your answers. Okay, and by the way, you'll always know if you got the right answers. Plug it into the original system and check and see that you get a true statement there. So is x equal 2 and y equal negative 3 correct? Well, is it true that 2 minus a negative 3, or 2 plus 3, is that 5? Yes. Is it also true that 2 times 2 is 4 minus 3? 4 minus 3 is 1. Yeah, that's equal to 1. Okay, so that's true. So it looks like x equal 2 and y equals negative 3. That's correct. Okay, or another way to give the answer would be to write it as a point. Okay, because you're really describing the point where these two lines intersect each other. Okay, so that's going to occur at the point 2, negative 3. Okay. Let's try another one here. So how about what if I had the system given by the equations 2x plus y equals negative 1 and 4x plus 2y equals 8. Okay, we'll solve by using the graphing method. So let me get each line into slope-intercept form, y equals mx plus b. So with the first line, when I subtract 2x from both sides, y equals negative 2x minus 1. And then the second line, if I subtract 4x from both sides, 2y equals negative 4x plus 8. So then when I divide by 2, y is equal to negative 2x plus 4. Okay, so these are the two lines that I have to draw. The first line has a slope of negative 2 and a y-intercept at negative 1. So 0, negative 1. We can use that as a start point there. And the slope is negative 2, so if I go up 2 into the left 1, up 2 into the left 1, or going up 2 into the left 1, the same thing as going down 2 in the right 1. Okay, and draw on that first line there. The second line, y equals negative 2x plus 4, that has a slope of negative 2 and a y-intercept at 4. So 0, 4 would be on the graph. And then work off the slope. The slope is negative 2, so go up 2 in the left one, up 2 in the left one, or going up 2 in the left one, the same thing as going down 2 into the right one. Okay, so if I go down 2 into the right one a couple of times, I believe that this line would cross the x-axis at the point 2, 0. Okay, and then I can draw on that second line there. Now my answer again is where the lines intersect. Okay, these lines are not going to intersect, right? Because they're parallel lines. How do I know they're parallel lines? Well, because parallel lines have the same slope. Okay, so these both have a slope of negative 2. They're not going to intersect. That means that there's no solutions to the system. Okay, so a system that has no solutions to it is called inconsistent. Or you could just make a circle with a slash through it. That also means that there's no solutions to the system. Okay. Here's another example. So what if I wanted to solve the system given by the equations y minus 2x equal 4 and 4x plus 8 equals 2y? Okay, let's get each of these lines into slope-intercept form. So if I solve for y, on the first line, let me add 2x to both sides. I'm going to have y equals 2x plus 4. And then on the second line, let me divide by 2 on both sides. So y would be equal to 2x plus 4. Okay, y equals 2x plus 4, that line has a slope of 2 and a y-intercept at 4. So 0, 4, I can use that as a start position. And work off the slope. The slope is 2. So I'm going to go up 2 into the right one. Or going up 2 into the right one, that's the same thing as going down 2 into the left one. If I go down 2 into the left one a couple of times, I believe that I'll cross through the x-axis there at negative 2, 0. Okay, and then I can draw on that line. So that's y equals 2x plus 4. And then I got to draw y equals 2x plus 4 again. So that's going to be the same line on top of a line. Okay, now my answer is wherever the lines intersect. So if I've essentially just drawn the same line twice, these two lines are going to intersect infinitely many times, right? So there's going to be infinitely many answers. Okay, a system that has infinitely many answers to it is called a dependent system. Now, my answer is going to be stated as an ordered pair. And in the ordered pair, I have to write everything in terms of x or y. Okay, so I'm going to write the point x, y, but in the y coordinate spot, instead of writing y, I'm going to write 2x plus 4. Now, this would be my answer. Okay, now this answer is a way to describe to somebody that there's infinitely many answers to the system. Because if you give me any x value, I can always find a y value, okay, by taking 2 times that number and adding 4. The point is that you can give me any x value, though, to start, right? So I'm going to have infinitely many solutions come up to this. Okay. Now, solving a system by using the graphing method has a major drawback. Often, we will not be able to accurately determine the coordinates of an independent system. Okay, like for example, what if I had the system given by the equations y equal 2x minus 6 and y equals 2/5 x plus 1? Okay, now we're going to use the graphing method on that. So if I were to make a graph, the answer is x equal 35/8 and y equals 11/4. Okay, now let me ask you, if I were to make a graph, do you think it would be easy to see this point? Or not really? I don't think it'd be easy at all to see this point. Okay, like if I'm using the graphing method, I'm usually selecting integer values for x and y, or maybe like a 1/2 or something like that. You know, so like seeing this point would be kind of difficult on a graph. Okay, so therefore it's necessary to know other techniques rather than just the graphing method. In fact, you know, some books don't even teach the graphing method, and they you know, just because these oddball answers. So some books kind of focus mainly on the substitution method and then the elimination method. Those to me are the kind of the more important ones here in this section. Okay, so why don't we stop the video here, and I'll talk about those two methods in the next video.